And on to horizontal parabolas. Take note, as I discuss this, that essentially what's taking place is x and y are changing position. And what that does, well, what once was y now is x, therefore our parabola, well, instead of being vertical, will be horizontal. The quadratic equation x equals ay squared determines a horizontal parabola with vertex at the origin. The coefficient a equals 1 over 4c determines both the focus at c0 and the directrix at x equals negative c. So here I've added some information from one of the previous slides regarding vertical parabolas. Take a moment to consider the two. Compare them and notice that a whole lot of the same information applies to both, except x and y have changed places. Example problem 2. Parabolas with equation x equals ay squared. Part A. What is an equation of a parabola with a vertex at the origin and a directrix of x equals 1.25? Well, one of the first things to note is listed here at the left. The directrix lies directly to the right of the vertex. Notice you should be able to observe that simply from the description in Part A without looking at the graph to the right. The parabola is horizontal. Well, that's one of the consequences of having a directrix directly to the right or the left of the vertex, or of having a vertical directrix period. Note our directrix is defined as the line x equals 1.25, making it a vertical line. Of course, a directrix y equals 1.25 would be a horizontal line. The directrix has the equation x equals negative c, recall from our definition on the previous slide. So c must equal the negative of 1.25, thus allowing us to write the equation of the parabola in a very similar fashion to vertical parabolas as being x equals 1 over 4c times y squared, which in this case, because c equals negative 1.25, is 1 over 4 times negative 1.25 times y squared, and that simplifies to negative 1/5 y squared. Check for reasonableness. Such a good idea in most any math problem. When you're done, take a moment to consider whether or not your answer is reasonable. That can help you avoid simple mistakes, like a negative sign where you should have a positive. Or an answer of 10,000 when 100 was the correct answer and you just had a decimal point mistake. So here's our check for reasonableness on example problem 2, part A. The equation is reasonable since the graph opens in the negative direction and a is less than 0. We already discussed the information in the plan box at the right, but if you'd like to take a moment to review it, you are welcome to do so. And part B, what are the vertex, focus, and directrix of the parabola with equation x equals 0.75 y squared? So here we're really working in the opposite direction. We're given the equation and asked to extract from that equation some of its components. This is a horizontal parabola. We notice that right away because of the x equals 0.75 y squared, as opposed to having something like y equals 0.75 x squared. So knowing that this is a horizontal parabola, we note also the vertex is at the origin. We can recognize that simply from the form of the equation being x equals 0.75 y squared, not having a plus y or a plus 3y or plus some constant to the right. So we recognize a from our equation as being 0.75. We know that a can take on the form 1 over 4c. And if we set the equation 1 over 4c equals 0.75, we can solve that as being 4c equals 1 over 0.75 and find that c must equal 1/3. Knowing the value of c, you can conclude that the focus is the point c, 0, which in this case will be 1/3, 0. The directrix is the line with the equation x equals -1/3. And this is an interesting thing to consider. At the right here, what does the sign of a tell you about the graph? Well, with a vertical parabola, recall that a positive a value meant an upward opening parabola, and a negative a value meant a downward opening parabola. Similarly, a positive a value in a horizontal parabola means the parabola opens to the right. And as you probably guessed, if a is negative in a horizontal parabola, the parabola opens to the left. And a chance to show that you have got it. Question 1 of 2. What is the equation of a parabola with vertex at the origin and directrix x equals -5/2? Work carefully and make your selection from the choices below. And question 2 of 2. What are the vertex, focus, and directrix of the parabola with equation x equals -4y²? Work carefully and make your selection from the choices below.